Hello and welcome to another All Nation Line video. I'm John Wubble and we talk about O-scale 2-rail model railroading. We're in the garden this morning because it's such a beautiful day, and we're going to talk about two topics. Our first topic, we're going to introduce a new product, which is our advanced premium grade flex ties. The second part of the video is a lecture I've done to introduce the hobby to STEM students and some of the key reasons why it should be considered as part of your career path. So stay tuned for that. Over the last 6 months, we've come out with various flex tie implementations for O-scale 2-rail. And here on the table are some of those that we usually display when we go to the train shows. We've done OW5 for the various code rails. We've done P48, concrete ties. We've done some of the ON3, and the ON3 is interesting because of the various types of narrow gauge that are out there, logging roads and so forth. So what you see on the table here is a sampling of some of our flex ties where we have hand laid various code sizes of rail. Today I would like to introduce the All Nation Line premium grade railroad ties in O-scale, and especially formulated to outperform the traditional wood tie used by modelers to hand lay track. After much research and thought regarding the physics of spiking into wood ties, our 3D printed flex tie strips feature the same characteristics as one would witness in the use of a wood tie when spiking down rail. Here's a individual tie. These don't look all that much different than the tie strips that we've introduced over the last 6 months. And as I noted previously, we're going to talk a little bit to STEM students about getting into the hobby of model railroading. And I think this is one example where if you were interested in the material sciences, something like solving a problem with spiking into plastics would be an interesting project. Interesting learning experience. And our flex ties are just like the other ones we've introduced for P48, OW5, and ON3. Before you either glue them down or spike these down, they're very flexible, and we're going to talk about a few of the features of this product. Now, on this old piece of true scale roadbed, we used a 7/16 inch spike and spiked down this code 148 rail, just to give you an example. And we can print these with or without tie plates. So some of the following features that make these premium ties the best on the market. Number one, 95% less likely to bend the spike as opposed to wood if hitting a hard spot in the wood. Number two, no pilot holes need to be drilled in order to push the spike into the tie. Number three, spikes will not tend to release or pop out over time or with changes in environmental conditions. And most importantly, the ties do not resonate sound compared to wood on wood or some of the other model railroad layout implementations. Thus, your trains will run much more quiet around layout. One exception, if the spike is long and travels through the tie into a hard road bed beneath the tie, sound may increase. So there's many considerations. Without taking a deep dive into the science and engineering, we can give you some background, and I strongly suggest you read our description on our website to get this background information about how and why these are premium ties. We don't get into the description around the CAD software to develop the tie or the printer parameters when we run it through the slicer for printing. However, there is one last attribute worth mentioning, and that's the durability. Now, in the past, when I've spiked rail, sometimes I slip with the pliers and mark or smash the wooden tie or deform it, and that's not a good look. With these ties, if you were to bend the spike for whatever reason, like you were going into a wooden roadbed that had a hard spot or a glue line, if you slip, you won't deform these ties. They're very durable. We'll think you find real value and performance with this product, even if it's only a short section of mainline on your model railroad layout. The next part of the video we're attaching here is to speak to students, STEM students, and if you wish to continue watching, you might pass that information on to someone you know, and we would appreciate it very much, because working through a career path, why not have some fun with a good hobby like model railroading? Thank you for watching, and if you get a chance, subscribe to our channel. Hello and welcome again to my YouTube channel, Brass Investments. Today I'd like to talk to STEM students that may want to consider model railroading as part of their career curriculums, if you will. It's not only a fun hobby, but there's so much to learn. And you may ask, well, what does that have to do with my field? Well, let me give you a little rundown. Let's say you're an IEEE student. You're interested in electronics. Well, in model railroading, there are a lot of electronics projects, not only under the bench, but within the equipment, locomotives, sound systems. This is a very interesting area, and one that does have some standards in the hobby, and so some of those standards could be innovative to study. Another area, let's say you're interested in chemistry. Well, let's consider the science of tank cars. How do you transport different products, materials, whether it's vegetable oil or fertilizers, crude oil? How do you build a car that can do that safely? That's an area that I think is very interesting and requires a multidisciplinary approach. Environmentalist. If you're very interested in the environment, there's a lot of areas in the railroading industry and also to consider in the hobby. One example I can think of is people want cleaner trains. If you would look at Florida East Coast, they have liquefied natural gas supplied engines now. Very clean burning, efficient, and well utilized on that railroad system. Safety is another factor environmentalists are very much interested in. There's so many areas of work in the industry to consider. Mechanical engineering, CAD programs, 3D, printers, lasers, CNC machines. It's got everything. You develop a model, sometimes you want to use that technology to solve some problems. Architecture or structural engineers, bridges, tunnels. There's all sorts of areas that are interesting. Computer science, there's coding, programming, train control, signals. So those are some of the relationships, right? And there's a lot of other areas, whether you're interested in economics, statistics, business, accountants, auditors, biological scientists, material scientists, geographers, cartographers, civil engineers, database administrators. And so as I go down the list, you'll say, well, what does that have to do? Well, in many areas where you're trying to innovate and solve problems, one of the things you have to do is build models. And we do a lot of that in model railroading. And I would say that, okay, I'm a biotech engineer and I want to invent a new fermentation process that I can develop and hopefully contribute to society? Well, you usually start out building small scale, right? You have to figure out what you need to have in the lab, the materials, the hardware, controls. It's not all that different than doing mock-ups, prototypes on different types of models that you want to build. The thinking process that's involved is very similar, and I would say that in a lot of these fields, just to get the hang of building models, as an example, it doesn't really matter what type of model you build. You're going to come away with some of the same practical, common sense solutions to arrive at something that solves a problem. I can think of, for instance, there was a documentary on blue baby syndrome. Dr. Vivian Thomas was a lab technician who worked very hard with Dr. Blaylock to solve the problem. And they documented, they took down their data. They had their models on paper, so to speak. And doing so, figured out that some of their assumptions were wrong, or they had missed something entirely. And so that is very similar to what we do in the hobby of model railroading, when we're trying to figure out a better way to build a model, the materials we're working with, the tools we have, and in some cases, when you're building models, you have to invent a new tool. So this is why I think it's important that STEM students consider the hobby, because it's an easy way to build your confidence and your skills, your mental skills, and there's something in it for everyone. I hope you enjoyed this video, and we're going to start talking about a few other interesting ideas to get into actually doing some brass construction on models, but we're going to talk about the prerequisites first. If you like this video, please subscribe, like, share it, and by all means comment.